So subnets is a range of IP addresses in your VPC. That's it. Simple as that. We know what a VPC is by now. We know that a VPC is a network that you can define in your AWS account. Inside of that VPC, you have something called a subnet, subnetwork. Got it? Subnetwork. A VPC is a network, and then a subnet is a subnetwork inside of a VPC. So you can launch AWS resources into a subnet that you select. So you create a VPC, and in that VPC, you create a subnet or subnets, many of them. You can launch resources into that subnet that you create. EC2 instances, RDS databases, different things you can launch into that subnet. You can use a public subnet for resources that must be connected to the internet. For example, your web servers, you can use a public subnet for them. And the public subnet is a subnet that has what? A public IP address. So a public subnet has what? A range of public IP addresses. A public subnet has a range of public IP addresses, whereas a private subnet has a range of private IP addresses. Okay? So, and then a private subnet for resources that won't be connected to the internet. So here you have 172.31.0.0/20. How many IPs does this subnet give you? How many IP addresses does this subnet give you?
We need to add it. We need to add it with CID.
No. Kwasi. Come on, guys. I've done this in class multiple times. Are we ready for class or should we cancel class? How many IPs does 172.31.0.0/20 give you? I don't
4,096.
What's that?
4,096 IP addresses.
And how many of these IP addresses are usable?
4,091.
Thank you. Guys, at this point, your cloud engineers, your SRE engineers, whatever you do to get the answer, I don't care. I don't care. You can Google the answer, whatever you want to do, just be professional about it and present your work correctly. I gave a homework and some people just do not Google it, take the image and send to me. No, that's very unprofessional. Please, I said provide to me the region names with where the region belongs, and I also asked for the airport codes. For example, North Virginia, the airport there is IAD, right? So I asked for the airport code. San Francisco, the airport there is SFO. You have to do some research. You have to really learn. You have to study, right? You have to learn for at least 2 hours a day, 1 hour in the morning, 1 hour in the evening, or if you want to do 3 hours at once, that's up to you, right? So that's what a subnet is. A subnet is a range of IP addresses. This is a range. This is a range. Okay. In this 172.31.16.0/20, what in this range is a net mask? Kobe. What in this range is the net mask? Kobe. This question is for you. What is the net mask in this range of IP addresses?
The net mask.
We talked about it last class. What was that?
I wasn't here fully for the last class.
No,
Still reviewing.
no, that's not an excuse. This class was recorded.
That's true.
Somebody help him out. What's the net mask in this range of IP addresses? What's the net mask? I don't know.
/20.
Correct. Guys, on Wednesday, I'm going to ask the same thing. I don't know if you guys understand me. On Wednesday, I'm going to ask the same thing. On Monday next week, I'm going to ask the same thing. My point is that you need to learn and know it. I asked the same thing last week, Wednesday. I asked it again today. Because the reason I'm asking is to see if you're studying, if you're dedicated to doing this. If you don't know what I've been repeating last week Monday, last week Wednesday, and then today again on Wednesday, then it means you don't want to do this. We're gonna stop. We're gonna stop. I'll guarantee you guys. Please, I'm spending a lot of time dedicated to this. Please, please, I'm begging you. Do your part. I'm doing my part. I cannot continue repeating the same thing for 2 straight weeks. Please. A subnet, this is a net mask, and this is a range of IP addresses. This net mask gives you 4,096 IPs, and 4,001 are usable IPs. Okay. So this is a subnet diagram. A VPC can span multiple availability. It means that when you have a VPC in a region, you can have many, many subnets in that region. A subnet is equal to an availability zone. In a region, you have something called availability zones. Availability zones are similar to data centers that sit in that region. Availability zones are similar to data centers that sit in that region. So for example, in US East 1, you have an availability zone. You have 6 availability zones. You have US East 1, US East 2, you have US East 1A, US East 1B, US East 1C, US East 1D, US East 1E, and US East 1F. Those are 6 availability zones. The API name or the code name for these availability zones or subnets is the US East 1A. That's what you will use when you use them in. That's what you use when you use them in your that's what you use when you use them in pretty much your AWS CLI or anything that you write on in your Terraform code, right? What I'm talking about, this is what I'm talking about right here. That's what you use when you use your provider.tf like this. This is the API name. This is the code name. This is the name that the program understands. AWS CLI understands this name as a region name. You're not going to type the word North Virginia. It doesn't understand this name. It understands US1. So the code name for this region, North Virginia region, is US1, right? And that region is US East 2. US East 2 is the region. This is the US East 2, sorry. And the region for this is Ohio. The name is Ohio. It's in Ohio. Similarly, you have US West 1. That's the code name. That's the API name. But this region is in San Francisco. San Francisco. The other region is US, that's West-2. It's in Oregon. This is the assignment I gave. This is what I expected, to see the name, the state where it belongs, and also the airport code. This is what I expected. For example, the airport code here is SFO, right? And then US, that's East. It's on Google. You can Google it. It's just the way you present the work it shouldn't show like, oh, I got it from Google, right? It's for your own benefit for you learn. The airport there is IAD, Dulles Airport. I don't know what the airport is in Oregon or Ohio. This is in Columbus, Ohio. It's in Columbus, Ohio. So the airport that is in Columbus, Ohio, that's pretty much it. Right? You need to learn this region and know them very well because you work in the United States. There are 5 regions in the United States. US East 1, US East 2, US West 1, US West 2, and what's the other region? It's a government cloud, AWS Gulf Cloud region. US-Gulf Cloud. Something like that. But these are the 4 regions that you need to really, really master. So what I'm saying is each of these regions have 6 subnets inside of them. US East 1 has 6 availability zones. Oregon has 3. San Francisco has 3. And Columbus has 3. So these are questions that they can ask you in an interview. You should know them. Anyway, let's continue. So a VPC can span multiple availability zones, but a subnet is always mapped to a single AZ. Let me go to the board and show you guys. 1 second here. So a VPC can span multiple availability zones. That means that in a VPC you can have many subnets, right? But a subnet is always mapped to a single availability zone. What does this mean? If I go to the board here, I want to explain. Any questions so far? Please ask. Ask if you have any questions. Ask, please. So as you can see here, you have this VPC here, this box, and you have a subnet. This subnet, for example, let's say it's US East 1-A. US East 1A is going to be mapped to 1AZ, one availability zone. The short name for availability zone is AZ. AZ. So it'll be mapped to 1AZ. And then if you want to create another subnet, the next subnet is mapped to another AZ. So a subnet is always mapped to one AZ, not to two AZs or three AZs, right? So US is 1A, US is 1B. In this VPC, you have two subnets, US 1A, US 1B. That's an example. So private and public subnets. A public subnet are used for resources that need to connect to the internet. A private subnets are resources that don't need to connect to the internet, or those that you want to protect from the internet. So this is a common question in the interview. They will ask you that if you have a database that has customer data, which subnet would you put that database in? The answer, you put the database in the private subnet because the database has customer data, so you have to put it in a private subnet to protect it from the internet. If they ask you that you have a web application that you want to serve, a web server, where would you put a web server? You put a web server in there, public subnet, because you want users to be able to access the website. So that's a very common question in there that they're going to ask you. So just mind note of that. A private subnet doesn't have access to the internet. As you can see here, there's no access to the internet, whereas a public subnet does. What makes a public subnet a public subnet? What makes a public subnet, guys?
Public IP.
The public IP address. And what makes a private subnet a private IP? What makes a private subnet a private subnet?
Private IP.
Yep, you got it. Private IP address. Okay, good. Let's create a public and a private subnet. This is not a VPC, right? We're going to create a subnet separately, right? So let's go ahead and create that. So we're going to go in here. We're going to create an empty VPC. Just empty VPC with nothing in it. Then we're going to go create a private and public subnet and attach it to that VPC. Okay. My network is very slow today. Network is extremely slow. Oh, wow. Wow, 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 wow. We create VPC. VPC only. I'm gonna just call this Project X. That's X. And we're gonna use this CIDR block 192.168.0.0/16. Kobe, how many IP addresses does /16 gives you? Kobe, a VPC of /16, how many IP addresses does it give you?
Is it 4,000?
Really? Really?
4,000.
Were you in class on Wednesday last week, on Monday, or the previous week?
I was in class Monday.
So as I was saying, my internet is acting up. Let's continue. We'll look at creating subnets when the connection comes back to be strong. A subnet can, what's the answer here?
D, only map to one availability zone.
A subnet can only be mapped to one availability zone. Let's talk about internet gateways. What are internet gateways? Anyone know? What are internet gateways?
Um, from what I know from my how can I say it? From my own knowledge, internet gateway, I think is just like a gate that gives access to data or some resources from the server to the public usage, I mean, to the internet.
Yeah, that's correct. Yes. An internet gateway is a device that AWS creates and AWS manage, right? An internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between your EC2 instances and your VPC and the internet. An internet gateway is created and managed by AWS. It's a managed service. AWS creates it for you. You use it as it is. It therefore imposes no availability risk or bandwidth constraints on your network traffic because Amazon manages it, Amazon creates it, and you just use it as it is, right? So if you need to connect your web servers to the internet, you will connect an internet gateway to your subnet, right? So you have your VPC, right? Then the VPC, you have subnets. You have a private subnet where you only have private IP addresses in there. And in that private subnet, you don't want to connect to the internet because you want to put databases in there. You want to put secure things in there, right? And then you want to have the web server where you want it to connect to the internet. So you put your EC2 instances in that public subnet, and then you attach an internet gateway to that public subnet. Now, that public subnet, because it has the internet gateway attached to it, becomes public. So when you create your EC2 instances inside of the public subnet, they will come up with public IP addresses because they have an internet gateway attached to that public subnet. Okay, that's how things work. This is very, very important because in an interview, for cloud engineering, they're going to ask you this type of questions, like how does an IP address generate, and how does a public IP address generated, right? A public IP, right? So to have a public subnet, you must attach an internet gateway to that subnet. So here's your wide area network out there, right? So the Spectrum, the Verizons, and then you have AWS in here, and then you have the internet gateway. It's what brings internet into AWS right here. You see, Amazon and everything. So that's pretty much what it is. You don't have to do anything for it. You just create it, attach it to a VPC, and then attach it to your subnet, and that's pretty much it. Very easy to use. I will do some practicals on that too. To allow your VPC the ability to connect to the internet, you need to attach an internet gateway. Like I said, this is the internet. This is your internet gateway right here. When you attach it to the internet gateway, if you attach it to the internet gateway and then you point the internet gateway to this subnet, right? You point it to the subnet, it makes this subnet a public subnet. If you don't point it to here, this subnet remains private. You can see the lock here is private. However, if you go and add this internet gateway to this subnet, it makes it public. So to avoid making this subnet public, do not attach an internet gateway to a private subnet. You leave it the way it is. Here, we're going to deploy databases and things that we don't want people to access. Okay? Any questions so far? Any questions so far? Okay. Good. Internet gateways must be attached to a VPC for them to be usable, right? You can create one. If you don't use it, then it's not gonna, it doesn't make any sense. When you create an internet gateway, you have to attach it to a VPC to be able to use it. All instances in your subnet must have either a public IP address or an elastic IP address. If you use an internet gateway, that means that in the public subnet, in this subnet here, all instances in this public subnet must have either a public IP address or an elastic IP address. We look at what the elastic IP address is the other day. Let's go back to what an elastic IP is. An elastic IP is what? An elastic IP address is an IP address that is reachable. It's either static or it's public, but it's persistent. Persistent means that if you restart your EC2 instance, it will come up with the same IP address. An elastic IP address is a static public IP that is collected, allocated to your account, and can be accessed to and from your instances. Some of the reasons why we use an elastic IP address is because in company, when you buy a software, let's say you buy Microsoft Office, it comes with the license key, right? When you put the license key in your computer, that license is attached to that computer. Now, if you sell your computer and you want to take that license key and install Microsoft Office on a new computer, it's not going to work because that license has been attached to your physical address, your IP address of that laptop. So in AWS, when we do create applications that use a licensed software, I don't think we'll do one, but like say you buy like a ChatGPT license, for example, and you install ChatGPT on your EC2 instance, on your Windows EC2 instance, it's attached to that IP address of that instance. So if you restart the server, it will disappear and you lose the license. So if you want to keep the license attached to the server permanently, you will go ahead and create an elastic IP address and you will attach it to that server before you install your ChatGPT license on that server. So that anytime you restart the server, it will come up with the same IP address, means that the license is mapped to the IP. This is one of the reasons why we use elastic IP addresses. Okay? Whenever you're dealing with licensed software, third-party licensed software that needs to be installed on that server, make sure you use an elastic IP address. Most companies don't really use it, but if you work with those old companies like the Lowe's, the Home Depots, they may be using this kind of systems, okay? Because they have legacy applications, which are very old. Okay, Lowe's, Home Depot, Best Buy, they have legacy applications. So all instances in your subnet must have either a public IP address or an elastic IP address. The default is public IP. That's the default, right? Unless you go create an elastic IP address and attach it to that instance, this is not the default. This is non-default, okay? Your subnet's route table must point to the internet gateway. So that I was talking about here. I was saying it here. To make this a public subnet, when you attach an internet gateway to that VPC, the route table for this subnet must point to here. That's how you associate this. It's called subnet association. Whenever you take the internet gateway and you associate the internet gateway with the public subnet, it makes this subnet a public subnet. Without an internet gateway, these two subnets will be private. But when you create an internet gateway, attach it to the VPC, and associate it with the public subnet, it makes this guy a public subnet, and this guy is still a private subnet. However, if you wanted two public subnets, you come out and take the same gateway and attach it to here, and this also become a public subnet. But whereas in the industry, this is the best architecture that we have, that we use, right? We always have a public subnet and two private subnets. This is the reference or best practice architecture. Okay? This is what you see on the job. Private subnet. So your application will run here. Your application will run here. Your databases will sit here and a private subnet as well. And then your web server will sit here. Or your website. Web server, your website. Website. Will sit here. Okay? So this is your application stack. Requests go down, right? And you have www.amazon.com, right? I've seen this before, right? Traffic goes to the public subnet, you see the website, and from there, the request goes to private subnet, goes to the application, goes to databases, and then the responses go back. Response, and then response, and then response back to the user. Right? So that's the response going back. And then this is the request coming down. Okay? So the network architecture looks like this. It's a public subnet, private subnet, and private subnet. And then you have your VPC, which VPC is this block here, VPC. VPC is the block. There's a VPC subnet. VPC. Yeah, VPC. Cool. That's your VPC.
Nico, I have a question.
Yes. Sure.
If you have in this diagram, if you have, for example, a load balancer,
Yep.
it's
What would
gonna
it
be
be?
inside. It's gonna be inside of the VPC also, or outside.
Yes.
So
That's a good
if
question. Your
it's
load
inside,
balancer will be. Go ahead. Finish your question. Let me find.
if it's inside the VPC.
Yes, it
That's
is
me.
inside the VPC. Yes.
Okay, that's me gonna be with a public subnet.
Yes. Thank
Okay.
you. Because the load balancer is what? The load balancer is what receives traffic from the internet,
Yes.
right? Right here. Let's use this one. He receives traffic from the internet. This is the guy. So, yep, he's gonna sit in here. I just arrow is blocking it, but yes, load balancer sits in there. He receives traffic from the met user and then spreads it to multiple web servers in here. Yes. let me see if I have this architecture to show you guys. SAL. I have a SAL architecture here. SAL architecture. SAL architecture. I don't have that. Probably in the documents. In document. SAL. This one. I'll find it. I have some diagram. I can just show you guys from the internet. The AWS 3-tier reference architecture. Reference architecture. Guys, learn how to catch fish, okay? What I'm teaching you is how to catch fish. Like, I'm not giving you the answers. I'm giving you how I look for it. This is how I look for things. Just Google it. Nobody really cares. Just Google it and get it done. We only care about getting the job done. That's it. Nobody care how you found it. Just become doers. You see here? Presentation tier, logic tier, database tier. So the client, which is your web server, will be in the public subnet. The server, which is your application, will be in the private subnet, and then your database will be in the private subnet. So this is what it looks like. I'm looking for an actual diagram. I should have a diagram, like a real diagram. Because based on this network structure, that's what you use. That's how you decide. That's how your network will be. So let's do this one. I think this is it here. This is a 2-tier or 3-tier. Oh no, this one. This one is good. I'll open it in the top. Yeah, this is perfect. There we go. Perfect. Can you guys see my screen? Is it clear enough or no? Should I zoom in?
Yes, let me see it.
Okay. You can see, right? As you can see, you have a public subnet here, you have a private subnet here, and then you have a private subnet here. So you see you have the databases in the private subnet. Your application servers are here in the middle. Then here you have the web servers. Then you have the load balancer spreading loads to the servers back here. Then you have two availability zones, USS1A, USS1B. So a VPC can span multiple availability zones, but an availability zone is only mapped to one subnet. You can only map something to one AZ. So this is one subnet. This is one subnet, one subnet, one subnet. Okay? But you can span multiple AZs like that. Okay? So to create high availability for your applications, you will have your application servers living in USS1A and USS1B. USS1A, USS1B. So that if one USS1A goes down, let's say there's a tornado in North Virginia, and all of North Virginia part of North Virginia goes down, you can still do business because USS1B is in the south area of North Virginia. Okay? That's what it's called high availability. So this is what it looks like. Okay. Same thing here. It's a YouTube video here. I'll copy this link and give you guys to watch a video. My system is slow today. I gotta restart my laptop. I haven't restarted in a long time. Why is the link so long? Why is the link so lengthy? You can see here, same thing here. I want to zoom this out. Here, public subnet, private subnet, private subnet. USS1A, USS1B, USS1A, USS1B, USS1A, USS1B. Load balancer spreading traffic to here and here. Another load balancer receives the traffic from these two guys. to the application and then spreads traffic to here and here. Then when I want to save the data, it goes from here to the database. Everything we've talked about in the past, pretty much. Same thing here. One public subnet, two private subnets. So it's an interview question. I have the answer right here. I think I gave you guys this one note already. The answer is there. I'm gonna ask you about how do you create a Twitter web application, right? If it's a Java application, all these things, right? How would you create a network environment? This is the answer, right? This is the answer here. So I have the answer pretty much written out for you. Okay, cool. Any questions on this architecture? Any questions on this architecture diagram? You have one public subnet and two private subnets. Okay. Any questions on this? Ask me, oh, ask oh. Okay. I'm gonna try to create an internet gateway. I'm gonna do the labs. Internet gateway allows for what to happen?
Internet access to your VPC as soon as you touch it.
I choose B.
Wasi, were you in class when I taught internet gateway?
Yeah. I was here.
Okay. Tolu, why did you choose A?
To be very honest, that deep quest, I just didn't read it. Like the text slanting over the B.
Oh,
I didn't pay attention to it.
I said it here, right? If you create an internet gateway and you don't attach it, would that subnet become a public subnet? No. No, right?
No.
Exactly. So you must attach the subnet. Where is it? Your subnet's route table must point to the internet gateway before it becomes a public subnet. Okay? So the answer is B, communication between your instances, your VPC, and the internet. Route tables. A route table is simply the rules that you create to attach an internet gateway to a subway. So a subnet. It's pretty much the rules or the routes in your subnet. That's all a route table is. Simple as that. It's similar to a security group. It just tells the subnet where I want the traffic to go. It's simple as that. A route table is simple as that. Okay? A route table contains a set of rules called routes, which are used to determine where network traffic is directed to. That's all. So if you have an internet gateway in your route table, what does that mean? It means the traffic is routed to their internet. If you don't have an internet gateway in your route table, you're going to have something called a local route. It means that traffic is only going to stay local within the private subnet. When you don't have an internet gateway attached to a subnet, what does that subnet become? Somebody tell me. A subnet without an internet gateway attached, what is that subnet called? Kobe. Kobe, a subnet without an internet gateway attached, what is that subnet called?
Private subnet.
Thank you. I was just checking to make sure you're here. You just left again. So a route table pretty much has a route that tells the traffic where to go. That's simple as that. Each subnet in your VPC must be associated with a route table. If you create a public subnet, guess what? You're going to have a public route table. If you create a private subnet, you're going to have what? A private route table. That's it. That's all. Finito. VPC is only VPC, subnets, internet gateway, and route table. That's it. That's the end of VPC. Finito. You create your VPC, you create your subnets. You have two subnets. You want one public, one private. The private, you leave it the way it is. You don't touch it. The public, you create an internet gateway, attach it to that subnet, it makes it public. You go to your route table, you associate the public subnet with that route table, and now you have a public route table. And you go take the private subnet and associate it to a route table and makes it the private route table. So you have two subnets. Each subnet has its own route table, and that's it. Finito, finito, done. So a subnet can only be associated with one route table at a time. So if you have a public subnet, it's going to have a public route table, and that's it. If you have a private subnet, it's going to have a private route table, and that's it. Okay? So a subnet can only must associate with one route table at a time, but you can associate multiple subnets with the same route table. Okay? But that's not best practice. Don't do it. Internet gateway diagram. Each VPC has a default route table. Your VPC, your AWS account comes to the default route table. So you have a default route table right in your account. It looks like this, right? It looks like it's like this. You have a local route, and then you have an internet gateway in that route table, in the main one, right? So it is best to leave it in its original state and create a new route table to customize the network traffic. So in your AWS account, you have your account, you have a VPC, that's a default VPC. You have subnets, you have a VPC subnet here and a VPC subnet here. Because this subnet is attached to a route table that has an internet gateway route. This is the internet gateway route here. This is a route. Kobe, this is a route. Kobe, this is a route, an internet gateway route. This internet gateway is attached to this subnet. And so this subnet becomes public subnet. Kobe, this subnet becomes public subnet because you have attached this subnet to a public route. This is a public route table. This is public. And then this subnet down here is private because we've attached this subnet to what? A private route table. This is private. It means the traffic is local. Local means that it only stays within the subnet. It doesn't go out to the internet. Here, this route here means going out to the internet. Whenever you see 0.0.0.0/0, it means open to anywhere to the internet. So this route in your route table, attaching this route table to this subnet makes this subnet a public subnet. Whenever you attach this route table to the subnet, it's called a route table association. It's called a subnet association. Sorry, not route table association. It's called a subnet association. Subnet association is when we attach a route in the route table and associate the route table with our subnet. That's what it is. Subnet association. Take note, some people in the industry don't just use the word subnet. They use the word VPC subnet. Okay, thank you for that. This is going to confuse you. VPC subnet is the same as subnet. because people are still coming into AWS, they want to be, they're very literal people. They call things the way they are. They call it VPC subnet. It's the same as the word subnet. But why are they saying VPC subnet? Because in Microsoft Azure with different cloud, they also have subnet. In Google Cloud, they also have subnet. But in AWS, it's called VPC subnet. So you want to make sure you specify. But we all know it's called subnet. So subnet in AWS is VPC subnet. You have VPC, which is the big guy. And then under VPC, you have VPC subnet. And then under subnet, you have VPC route table. And that's it. Just three components is big, bigger, biggest. Big, bigger, biggest. VPC is the main thing. Then you have, so if it's a subnet, then you have the route tables. That's it. That's all about VPC. Every other thing, like the internet gateway, you attach it to here. NAT gateway, attach it to the subnet. Everything is attached to the subnet. And then subnet is attached to the route table. That's it about VPC. That's it. That's done. That's all. No more.
I am really bit lost. Okay, what I understood of the beginning, internet gateway is attached to a subnet.
Yes.
At the beginning,
I don't want you to cram it. Don't cram it, guys. Don't cram. Let's understand it. If I need to pause recording, I'll pause recording. Don't cram it. I need you guys to understand it. Right? Let me go back to the board. Kwasi, I like your questions. We're not in a rush. We're not in a rush. I want you to understand it. You have a VPC, right? Inside this VPC, you have subnets. This VPC is what? This VPC is what? It's 10.0.0.0/16. Isabel, Tolu, Kwasi, Chris, are you guys tracking? Yes? I need
Yes.
Yes. Stay with me. A VPC is a CIDR block of a network that you define. So this is our VPC that we're defining. This VPC gives us 65,531 usable IPs. Usable IP addresses that we can use. So in this VPC now want to create subnets. US-East. This VPC that we'll create is in which region? It's in US East 1. That's the VPC region. We want to create subnets in here. We want to create one. US is 1A. That's our first subnet. This subnet, we want it to have 4,096 IPs. So we're going to do, it's going to give us, it's going to be 10. Oh no, what's happening? In this subnet, we're going to have 10.0.0.0. Oh no, sorry. Yes. .0/20. That's our first subnet. Our next subnet is going to be what? US East 1B. And it's going to be 10.0.0.16. .0/20. Our third subnet is going to be what? US East 1C. 10.0.0.32.0/20. Our fourth subnet is going to be what? Let me expand the VPC. US East 1D. Don't try to cram it. Please understand it. 64. So this VPC gives us 65,531 usable IPs, correct? Each of these gives us what? 4,000 each. Yes? So if you add 4,000 times 4, what is that? 16,000 IPs. So subtract 65,531 minus 16,000. You still have more IPs left in this VPC. That means you can add more subnets in this VPC. That's it. Kwasi, did you get it now?
I get it this part.
Huh?
Yeah, I get it this part.
Is everybody clear up to this point? I want to build on the knowledge of our learning. Is this one clear?
Yes.
This VPC is going to give you 65,531 usable IPs. If each subnet is 4,096 or 4,091 usable IPs, so what is 4,091 times 4? Somebody did the math. I didn't go to school. I don't know math. What's the number?
$16,368. Sorry, 4,091. Oh, 91. 4,091.
16,364.
64.
$16,000?
364.
So 16,364 minus. So 16,364. If you subtract this from 65,000, what's the balance left? Usable IPs?
49,167.
49,167 is remaining in this VPC. That's what it means. So it means we can come here and create more subnets in this VPC and expand the network and grow the business, create more applications, have more customers, enterprise company. That's what it means. Now, this is good and fine. This is good and fine. Let me expand this again more. Let's build on what we've learned so far. To make these two subnets up here, because we want to run, if we want to run a web server in these two subnets, so we want two public subnets, what are we going to do? We're going to attach what? An internet gateway to this VPC. So we say, okay, let's attach an internet gateway here. This is what? Internet gateway. Okay. That's an internet gateway. Because we want to make this, subnets public. These are subnets, right? We want to make them public. So we're going to attach these two subnets to the internet gateway so they can become public. So we have attached them. But the question is, how do you attach them? How do you associate them? You attach the internet gateway to the VPC first. This is the VPC, by the way, right? Then using the route table, you associate them in their route table. You go into the route table of these subnets and you add a route for internet gateway. That's it. You add this right here. You go to destination, you add this, and you add the target internet gateway. So now, these two subnets, whatever HTTP instance you create in these subnets, they can communicate with the internet. This is the internet out here. So to make this subnet public, you attach an inner gateway to the VPC, and then using the route table, you associate them to the subnet. How? By adding this route in the route table. The route table looks like this. Let me show you guys the route table. Maybe that will help. Oh, I've been signed out. Trying to sign in. Let me try to sign in again. I don't know what's happening to my account. Can't sign in. I need to restart my laptop. But that's how a route table looks like. Okay. Is that clear so far?
Yes, yes.
Okay. So you know how to make a subnet public by attaching an inner gateway to the VPC, and then you attach the route table. Using the route table, you add a route in the route table and attach a subnet to the gateway. That subnet is now public now. These subnets are still private. By default, when you create a subnet, hello, everybody listening to this. By default, when you create a subnet, the subnet is private by default. Kobe, when you create a subnet, is a subnet public or private by default?
Private by default.
Okay, you're still there. It's private by default. Unless you go and create an internet gateway and attach it to that VPC and associate the internet gateway with a route with a subnet using the route table. The only way in which you can associate an internet gateway with a subnet is by going to the route table and adding a route in the route table that says internet gateway. When you add this route to the route table of that subnet, the subnet becomes public. If you don't add a route like this in the route table of that subnet is private. When you create a subnet, it creates a route table by default. The route table by default is this. It says /16, and it's going to show local. It's going to show local because it's a private subnet. All the traffic within that subnet stays locally within that subnet. So it's called a local route because it's local to that server. Local. I'm speaking Akata. Local is local to that environment. If you want traffic to leave this EC2 instance and go outside to the internet, you must go and create an internet gateway and attach it to the route table to make that subnet public. Then now traffic can leave this server and go out. Is that clear up to this point?
Yes. If Jerry, the route table is able to make a distinction between private subnet and the public subnet. Okay.
Yes, you got it. I'm happy. So these subnets here remain private and these guys are public. And that's it. That's it. You create your VPC, you create your subnets, and then you use the route tables and associate them to this gateway, and that's it. Done. VPC is over. That's it. So you can create a custom route table. You can see it says custom route table because by default, when you create a subnet, it creates a route table for you. So if you want to create your own, if you want to customize your network, if you want to make your network, customized, there's always a main route table of that VPC. But if you want to customize it by adding an internet gateway, then you go create your own custom route table. That's why it says custom here. It's very easy. Stuff is very easy. Which of the following is not true about route tables? It's not true. Not true means the opposite.
C.
What's that?
C.
Yep. It's not true. Every VPC has a default route table. It's good practice to leave this in its original state and create a new route table to customize the network traffic. So always create your own custom route table. Do not use the default one, right? Not devices. We're not going to look at them. Not gateways. Simply, let's look at not gateway. Question. Let's go back to this. I have a question. You have an EC2 instance in here. EC2 instance, where is it? Yes. No, this is image builder. EC2 instance. Right here, this one. Huh? EC2. Yeah, this one. Kwasi, you have an EC2 instance in, or anybody, class, Mr. Bell, Tolu, this is as well. Let's brainstorm here. I want us to think a little bit out of the box. Okay, we said that and you have a database too. Let's put RDS. Database. No. Let's do database. Yep. No. Database. We said when you put any resource in a private subnet, it has no access to the internet, right? It has no access to the internet, no access to the internet. So this is a database where we store customer data. This is an EC2 instance where we run our applications. Okay, cool. But now we want to do an update. You know what a software update is? Like a software update. If you go here about this mark, I need to run an update on this lab, like a software update, right? Like an update the software, right? So if I want to run an software update, I need to go on the internet and download. I need to go to the internet and download the packages, right? The software updates, right? And then install it, right? So my question is, if I want to update this EC2 instance, like I want to run a Yum update, and I want to update this database, but then a private subnet, and I need to download the update from the internet. How do I go to the internet and get the update for this EC2 and this database? How? Anybody have an idea? Let's think for a little bit. Let's think about it for a little bit. Let me pause recording here. So using a NAT gateway, you can update resources that live in a private subnet. So what does that mean? That means that using this NAT gateway, this instance that is in a private subnet, it doesn't have a public IP address. This EC2 has only a private IP address because it's in a private subnet. This database has a private IP address as well because it's in a private subnet. They don't have a public IP address. So they cannot go to the internet to get any downloads on the internet, right? They don't have a public IP address. Without a public IP, you cannot access the internet. Without a public IP, you cannot access the internet, right? Okay, so what does that tell us? That tells us that the NAT gateway is a device that would take this EC2 request. EC2 connects to NAT gateway and takes this request. And then this NAT gateway now, because it's in a public subnet, we go out to the internet. We go out to the internet, right? And download the software, right? let's use the cloud. This is the internet. Let's use the cloud icon here. Let's just see. Right. This is the box, internet. It goes and download whatever it needs to download. And then it will bring it back to here. It will bring it back to here and then give the EC2 instance a download. That's it. This isn't you will never get a public IP address. This NAT gateway is just there as a device. It's called network address translation. So this network address translation gateway translates the EC2's private IP address into a public IP address, goes out to the internet, downloads the material, brings it back and give it to him. He remains in a private environment. It's a one-way traffic. It's one-way traffic. The request goes out to the NAT gateway. NAT gateway goes and grab it and brings it back to him, and then he collects it from here and bring it back. So then this guy never goes to the internet. He ends here in the NAT gateway. This is an interview question. This is an interview question. This is an interview question. The NAT gateway is a device that an EC2 instance in a private subnet uses to get updates from the internet. So we've learned one type of gateway. We've learned an internet gateway, which is what gives you internet to your public subnet. This is the last gateway we're learning. NAT devices. Network address translation device enable instances in the private subnet to connect to the internet or other services, but prevents the internet from initiating connections with them. So I'm in the private subnet. I want to open my EC2 instance. My EC2 instance can go to the NAT gateway, and then from the NAT gateway, translates my IP address, my private IP to a public IP, goes and get the packages for me, downloads it for me, and bring it back and give it to me. But someone in the internet cannot connect to me in the private environment. It's a one-way traffic. You know, remember those roads? When you're driving on a one-way road in downtown Dallas or wherever you live, it's a one-way. You can go, but you cannot come back on that same road. That's what this is. Yes, that's a perfect example. It's one way. So you can connect your private subnets or databases to other AWS resources if you use a NAT device. The NAT device sits in the public subnet. You can see here. These instances here are private. They cannot go to the internet to get any kind of downloads. They will have to connect to this NAT device. Then the NAT device will go and get the downloads of them and bring it back. That's simple as that. So NAT gateway so AWS provides two sets of NAT devices. You have a NAT gateway or NAT instance. NAT instance has been deprecated. Deprecated means we don't use it anymore, right? It's gone. It's been terminated, right? Now we use NAT gateway because anything gateway is owned and managed by AWS. 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 Okay. Any questions so far? So I can say a NAT gateway must be launched in the public subnet. This is an interview question. They'll ask you, hey, Kobe, you deploy your application in a private subnet, and because it's a Java application, right? This is a Java application. You need to update the Java of that server. What would you use here Well, how would you update the server? Oh, I will deploy a NAT gateway in the public subnet, and then the Java server will connect to NAT gateway to get the Java updates. That's it. If it's a database, an Oracle database, you want to update the database, you deploy a NAT gateway and you connect the database to the NAT gateway so the database can get updates on the internet. But that's it. That's your answer. Is that clear? It's easy, right? NAT gateways are very easy, right? Yes?
Yes.
All right, cool. And that's it. And that in the subnet, when you create in the public subnet, you add a NAT gateway like this. Again, it's the internet, so you just add a NAT gateway route, and that's a route. Simple as that. Similar to how you have internet gateway route, you have a NAT gateway route, and that's it. Done. Reserved addresses. Reserved NAT addresses. Amazon reserved this address, the first IP, the last IP, right? And then Amazon has also reserved 172.16 to this. Amazon also reserved 192.1 to this address. So Amazon owns all these addresses. For a NAT gateway. Why does AWS recommend using the NAT gateway? Why don't we use a NAT instance? Why do you use a NAT gateway? All of the above are correct.
All.
Yeah, everything, right? Whenever you hear gateway, it's because Amazon manages it. It provides better availability. It has redundancy, all these beautiful things, right? Gateways are the best way to go. Always use a gateway over an instance. If you use an EC2 instance as your NAT instance, you will have to manage it yourself. You have to do it, manage it manually. But if you use a NAT gateway, Amazon manages it for you, right? Right? You don't want to use an EC2 instance to do this to work. Let Amazon do it for you using the gateway. Okay, cool. What does a NAT gateway require to function properly? This is an interesting one. Let's see. I did not talk about it, but I want to see if you guys can get it.
Either B or D, but I'll say B.
Isabel, what's your answer? See, it's gonna be this or that. So you got to pick one. Confidence.
Say B. B.
Guess what? You're right. Whenever you hear the word gateway, anything gateway, not gateway, any other gateway is public. Hello, guys. I don't know if you guys are getting the hint. Gateway is another word for public. Oh, there's no private gateway. Not gateway, public. Any other gateway, public. Load balancer, public. Yes, is it registry now? A NAT gateway must be launched into a public subnet and have an elastic IP address as it requires internet connectivity. Let me correct this. This is an old statement. I don't think you need an elastic IP address anymore. Amazon may have fixed that issue where you have to attach an elastic IP. I don't think so. I have to double check because this document, this is my slide, I've been using it for over 6 years, this document. So I think Amazon, because elastic IPs are very expensive. And elastic IP is very, very expensive because think about that. Think about you buying a specific IP address and owning that IP address forever. Like, think about that. It's so expensive. So customers have been complaining about that. So I'm sure Amazon like, okay, we're not gonna let you pay for it. We're gonna add it to the because some customers have moved from AWS to Microsoft. I've moved customers from Amazon to Microsoft, from cloud to cloud, which is weird, but you know, like United Airlines, yeah. United Airlines moved from AWS to Microsoft Azure, in Chicago, the headquarters in Chicago. But yeah, so anytime you hear the word gateway, think public, okay? Gateway public, okay? Just have that in mind. Again, don't cram this stuff. Try to understand it. If you can understand it, let it go. That's my rule of thumb. If you can understand something, let it go. Move on to the next thing. Try and learn to know what you know. If you know EC2, know it well. So well that you're an EC2 expert. If you know S3, know it so well. If you don't know VPC, it's okay. Don't kill yourself. Know what you know, let it be. But try and pick an area where you're an expert in it. They will ask you in an interview, among these 5 services, which one are you an expert? EC2, IAM, S3, VPC. And what else have we learned? RDS. Which one are you an expert in? You say, I'm an expert in S3. Okay, boom. Let's go with S3. They're going to ask questions on S3. You cannot be a jack of all trades, master of none. Pick your area where you know that you're a master, that you've mastered it very well. This is my advice to you. This IT thing that we're learning, there's so much to learn. There's so much that you need to know to get a job. Yes, we get it. But when you get to the front of the interview, the interviewer will look at a resume. Oh, you have some good experience. What area are you very good in? Are you good in S3? Security? Sorry?
I am the easiest.
There you go. You think IAM is the easiest until you get to the interview. And trust me, you're right. IAM is in high demand. Every company use IAM every single day. IAM is in high demand. In fact, if you know IAM very well, your chance of getting a job tomorrow is very, very high. You know why? Because you need to manage users' authentication and authorization. Oh, he needs access to this. Oh, he needs access to this. Oh, let's give him access. Oh, remove his access. Oh, we need more. Every day is access removal, access addition, modification. Every single day we deal with access controls, access this, access that. Oh, authorize this. Okay, we'll have a new hire next week. Create a new role for that new hire. Oh, this is it's in high demand. IAM is used with everything. To create EC2 instances and attach S3, you need IAM. To create this and that, you need IAM role. To create multiple accounts, IAM. IAM is everywhere. If you want to be an IAM expert, let me know. I'll give you some extra calls to take. And it's not like 5 hour calls. And you can just go them as an IAM. You can go them as an IAM engineer. I don't know how much they pay. I think the pay is good. And that's all you do every day. That's all you do every day. That's all you do. You won't do anything else. That's all you do. There are jobs out there for IAM people, right? See, there are jobs out there for them. Design, maintaining IAM technologies, audit, compliance, right? There are jobs for IAM on Indeed. That's all you do. Okay? But yeah, let's continue. Let's not go out of class. But yeah, if IAM is your expertise, then by all means follow that. If you want to be a cloud engineer, DevOps engineer, then try and know a little bit of everything, but be an expert in one. Last thing, security group. Security groups. After you have created your VPC, let's go here. Oh, look at that. IAM engineers. How much are they paying? Okay, let's just focus on class for now. You created your VPCs, create your subnets, do your internet gateway attachment, all that stuff. And now, you want to now you want to connect to it. That's where your security groups come in, right? You have your connection, your subnets, you have your private subnets, you have your internet gateway attached to this. This is a public subnet. Now you're out here, not as a customer, as an engineer who works for the company. You want to connect to your instances, right? To manage them. That's when you need what? Security group. That's it. That's the last piece. Security group. And that's the last piece before, but Kobe's like, this guy said last piece many times. Kobe, this is it. VPC subnet, route table, security group. That's it. On the subnet level, you have two things you can attach. Internet gateway, or what? Or what? What is another thing you can attach to subnet? What's that type of gateway? Kobe, waiting for you. Kobe.
Yeah, the
He's not here, man.
route.
There are two types of gateway you can attach to subnet. Internet gateway, what's the other gateway? Kobe's not here, man.
I'm here. I'm here.
Somebody help him out, man.
The
We just
NAT,
talked about it.
the NAT gateway.
Kobe, what's going on, man? What's really going on with you, man? Are you here? You're doing something. You're clearly doing something, man. Clearly, you're doing something else. If you're here, I said NAT gateway. Everyone else heard it, but you, come on, man. I'm gonna call you after class, man. Let's have a man-to-man conversation. NAT gateway. That's it. And then you associate the route tables, the VPC on the route tables, and that's it. And then you have security groups that allows user connections. All of this setup is good, but for you, the users now to connect to your EC2 instance in the subnet, you need a security group. A security group acts as a virtual firewall. It's a firewall. That's it. Simple as that. A firewall. So a security group is a firewall. That controls traffic for one or more instances. So now this is not related to subnets, it's your instances that are in your subnets. You add rules to each security group to allow traffic to your EC2 instances or from your EC2 instances outside. That's what security group is. It's simply a firewall that protects your EC2 instances. That's it. Your EC2 instances. Let me go to the board. One more time. One more time. Let's drive this point home. Okay, no, let me use the existing diagram. So this is the subnet. I'm going to expand the subnet. Boom, there we go. Your security group is this. Security group. Let me space it out. That's it. This is a security group. Because you create your instance in a subnet, each subnet can have its own security group. Like that, boom. Boom. That's it. This subnet security group controls who can log into that instance in that subnet. That's it. You have created everything fine. It's public. Yes, this is public subnet. This is private subnet. Yes, but how do you control who can log in and do what? Using security groups. That's it. Okay? So security groups control what can and what cannot access our instances that reside in a VPC. That's it. Let me charge my laptop, guys. Give me 1 second here.
Okay.
It's done. Is that clear? Any questions on that? On what security group is? It's very, very straightforward, right? You have created everything. Yes, it's good. It's working fine. But how do you control access to it? Using security groups. Any questions? Any questions for me? You can see here, security group controls what can access it, right? Here it's a public subnet. You have the security groups. In that security group route, you have who can access this instances in here. Same thing in here, all right? This is the security group. Let's take a look for examples. The web server needs to receive traffic from the internet. So when you want to receive traffic from the internet into your web servers, you need to have HTTP and HTTPS protocols, right? Kobe, a website uses what protocol if it's a secure website? HTTPS, right?
Yeah.
Right. So in your security group, you need to have HTTP and HTTPS ports. A port is simply a door in which you let traffic in, like the word C port. So security group allows you to control the traffic that comes into your EC2 instances. So since we need to create a web server, that allows traffic that comes in to our servers, we need to create a rule, a security rule, HTTP, TCP, port 80, and then allow traffic from the internet. HTTPS, TCP, port 443, because 443 is a secure port number, allow traffic from the internet. So in this case, all traffic that is coming from the internet that is not HTTP or HTTPS will not be allowed, will be blocked, because we've only allowed HTTP and HTTPS. All other traffic will not be allowed. SSH connections, database connections will not be allowed, because this security group is for a web server. Next example, databases. This is a security group for databases. Like I said here, each subnet can have a security group, or we can have a security group for each thing. We can have a security group here for this subnet, security group here, security group here. So we can have a security group for our database. We can have a security group for our web servers in here. We can have a security group for our application. This is the best practice architecture. This is it, right? This is how it looks, right? So for a database security group, since it's Microsoft SQL Server is a database, and RDP is also a database, Windows database, Windows connection, sorry. We're allowing these two traffic. Microsoft SQL Server TCP 4.1483 anywhere, and then RDP TCP 3389 like this. This is for a database. All other traffic will not be allowed. Only these two will be allowed. So by default, security groups allow all outbound traffic, right? So security groups normally allow inbound and outbound. That means traffic coming in is called inbound, traffic going out is called outbound. By default, all outbound traffic is allowed. So that means that whatever comes in will go out. That's what it means. So security groups rules are permissive. Permissive means that the rules allow you to do something. If you don't have a rule, then nothing is done. If you create a rule, then it allows you to do something. So security groups are stateful. Stateful means that whatever comes in will go out. Security groups are stateful. Whatever comes in will go out. Interview question. What are the differences between subnets and security group? Write this down. This is your homework. Homework. What is the difference between security group and what is the difference between security group and subnets? What is the difference between security groups and subnets? Security groups are stateful. Subnets are stateless. Security groups, whatever traffic comes in, must go out. Subnet, whatever traffic that comes in, must not go out. It can be blocked. Security groups, you can modify the rules of a security group at any time, and the rules are applied immediately. Okay? Create a security group. We'll do that. Which of the following statements about security group is not true? Which of the following statements about security group is not true?
Option B.
B.
Security groups are stateful. For any request that comes from your instance, the response traffic for that request is automatically allowed to flow in, regardless of what inbound security group rules you have configured. So whatever comes in will go out. It means it's stateful. And that's it. We're not going to do network ACLs. VPC best practices. We're done with VPC. Best practice, private and public subnets. The default, always use NAT gateways for private subnets. Choose your setup blocks correctly, and also understand Amazon VPC limits. Use private subnets to secure resources that don't need to connect to the internet, such as database servers. This is an interview question. Use NAT gateway over NAT instances to provide secure internet access to private subnets. Amazon VP can contain 16 to 65,536 IP addresses. Kobe, take notes. Kobe, take note of this. Create separate Amazon VPC for development, staging, and production environments. So separate the environments by using different VPCs. Create one Amazon VPC with separate subnets. Do not use one subnet for everything. Always have public subnets and private subnets. The limits, there are 5 VPCs per region. 200 subnets per VPC, 200 routables per VPC, 500 security groups per VPC, and 50 inbound, outbound rules per VPC. Some rules can be increased by raising a ticket with AWS support. Use security groups for whitelisting and network ACLs for blacklisting. Create different security groups for different tiers of your infrastructure architecture inside your VPC. So it means that create a security group for web server layer, a security group for application layer, and security for database layer, right? Do not use one security group for all. Separate security groups so I can separate traffic and have more security, network security. What else? That's pretty much it. VPC costs. And then you're going to do these assignments, guys. Build a custom VPC. This is your assignment. Build a custom VPC. Use the custom learned in this lesson. Recreate a custom VPC as shown in these recommendations. VPC name, my VPC. Setup block. This is the setup block. Subnet 1, public subnet, and private subnet placed in separate availability zones. Internet gateway 1, NAT gateway 1, route table 1, security group, web server security group, and database server. This is a group work. You can do it as a group or an individual. It's up to you. And that's it. We're done with VPC. Next class with the connection, I'll create all these things on using the console, and then we're also going to go and create using Terraform as well. Okay, we did not take a break today. I'll give you guys the last 10 minutes of the class to take a break, and then we'll meet again on Wednesday. Let me see if I can log into my account again. Let me try now. Any questions? Kwasi, let me just explain what you asked in the beginning of class, right? You said when you create something, right? So what you have to do is you have to, when you want to create, let's say you have created EC2 instance here, or let's say you create a VPC here, right? And then now you want to create an EC2 instance. If you run this same code again, it's going to create another VPC. So what you want to do is you want to comment your code like this, Control/. You comment your code, and then you save the file. You save it. So when you run now, it will only create EC2. It will not create a VPC again. You got it? That's it.
Yeah. Okay, thanks.
Okay. That's it for today, guys. All right, guys. I'll see you on Wednesday. Good night.
Good night.